This is part of a 10 session series or 10 module series. Last week we dealt with where are the carbon emissions in buildings, but today's all about how to get to net zero carbon cost effectively. You recall in the first session, if anyone wants to see that, it's on the Academy part of the RIPE Office website where we talked through this in detail. But what we found last time was that fit out accounts for 43% of the emissions, and we learned all about the difference between embodied emissions and operational emissions, and how in fact the embodied emissions, which is the emissions in stuff, is actually 70%, whereas the operational emissions are only 30% of the footprint of a building over its lifetime carbon emissions. So what's net zero carbon all about? Well, net zero carbon is the idea that we need to limit our temperatures to 1.5 degrees Celsius increase above pre-industrial levels. And so what does that really mean, and how do you translate that to action? Well, the organisation that is best respected for its standard around how to do that is the Science Based Targets Initiative, and their standard requires a 50% emissions reduction before 2030 and a 90 to 95% reduction before 2050, which includes all of your supply chain carbon emissions. So that's right through to your suppliers, your suppliers' suppliers, your suppliers, literally right the way back as well, obviously what you do as a company or as an individual. The key thing here is there's been a lot of talk about offsetting for the last sort of couple of decades. Well, what the Science Based Targets Initiative has said is, look, offsetting sort of okay, but we really should be doing everything else first. And so what they define as hard to decarbonise emissions, you're only allowed to offset 5 to 10% of those. That is, you need to hit the 90 to 95%, and then you can start to offset with genuine activities that take the carbon dioxide out of the atmosphere. And there's a graph there that says, look, we're probably already over one degree. This is an IPCC chart, and heading really quickly towards 1.5. So we really need to do something serious about that. And that's the science that SBTI has translated into targets. So how do you decarbonise? So remember, operational emissions are 30%. The options for doing that are renewable energy, and there's 3 points to consider there. So there's grid, what we call grid renewables. So that's where large utilities and producers are creating large scale, either solar or wind or hydro, and then feeding that into the grid, and simply by asking your supplier to provide you with renewables, you can do that for roughly the same cost as non-renewable electricity. So why wouldn't you do that? That's pretty easy. There's on-site renewables as well, a lot trickier to do because you're sort of limited in how big you can go before you run out of either roof space or wind turbine approvals or whatever that looks like. And the key thing about renewable energy is that it comes through the electricity grid. That means in order for you to be using that, you need all electrical appliances. So it's not much good switching to renewable electricity if you've then got some massive coal-fired or gas or oil-fired boilers, which are not obviously not benefiting from that renewable sourcing. So you must have all electrical appliances if you're relying on renewable energy to get your operational emissions down. Of course, as well, on top of that, there's energy efficiency. LED lighting is a massive opportunity to reduce emissions by quite a lot. Variable speed drives, building management systems, etc., right through to copying machines and coffee machines and everything being more efficient than they used to be. And there's always some choices there. The problem with most of those energy efficiency solutions is they require an investment up front. Now, no question they should pay themselves back because that should be part of your business case. But there is a greater upfront investment required, which in some circumstances for some organisations becomes a barrier. So that's operational emissions. Now let's turn to embodied emissions. Now, obviously the ideal for embodied emissions is that we use materials that actually remove carbon dioxide from the atmosphere. So these are what's called carbon negative materials, and so that's a really good option if you can get them. And there's a few examples around. So Interface spent a very long time coming up with a range of carbon negative carpet tiles where the materials within that are bio-based and would otherwise go to waste, and so therefore they're essentially locking up that carbon from going to the atmosphere. There's some really proactive stuff like graphene technology now included in paints, and so once that's applied to a wall and dried, it actually sucks in carbon dioxide. I'm not sure the volumes are particularly large, but nevertheless everything counts. And then there's a couple of companies that do boards made from wood waste, so is counted as carbon negative. So some interesting alternatives there, traditional products, but that unfortunately currently mostly they're a bit more expensive than traditional products, creating therefore another cost barrier to change. And of course, I'm going to summarize this all in a 2x2 at the end about cost versus effectiveness. The next set of options that we consider for embodied emissions, and my page is not changing over. Why is that not occurring? There we go. Is the circular economy. Now, we know what the linear economy is. Everyone on this call knows that ends up in landfill, single use, not very efficient. The circular economy is all about turning things into cycles, just as it says on the tin. And there's a whole bunch of great circular economy fit out solutions out there, from recycled ceramic tiles, ceiling tiles, paint, reclaimed flooring, remanufactured raised floorings, remanufactured furniture, AV and IT, and even reused kitchens. So frankly, that's most of the elements in a building other than in a fit out, other than maybe walls, doors, air conditioning systems and other services that might need to go in. So there's tons and tons of options around that. There's even some great lighting systems out there now that are second life and remanufactured. So lots of great options there. So what's the story about the circular economy? We hear a lot about it. Well, there's a couple of different flavors of circular economy. So there's the reuse repair, which is obviously low cost because it's your product and then you're reusing that with whatever fix-ups are needed. The problem is, if you're moving into a brand new, freshly painted office that's all beautifully designed, having scratches and worn fabrics and tears and all that sort of stuff is not a particularly good look. And so for high quality office fit outs, reuse and repair as is not a particularly practical solution. However, remanufacturing, that's the one that we're really excited about because it's lower cost than new, it's as new quality. There are very substantial carbon savings. The figures that we use are 80%. Talking with others, they think it's closer to 60%. So 60 to 80% carbon savings and obviously avoided waste. The con with remanufacturing is that incumbent suppliers rarely offer it. They might talk a little bit about it, but practically most incumbent suppliers of products are selling what they've always sold, which are mostly made from virgin materials. So there's a little bit more work required to find trusted suppliers. However, it's ideal for offices if you can find those suppliers. Third option then is recycling. Now, there's a lot of organizations pushing recycling, and really we don't like recycling very much because it's breaking materials down to its modular level and then rebuilding them back, which of course has a whole lot of two-way emissions, both in taking that product or getting it from where it was used in its first life to a recycling facility, breaking it down, putting it all back together, and then doing all the steps that you would do to make something from virgin materials, albeit without the biodiversity loss of the mining. And that then it means that your environmental footprint in terms of the energy used, the water used, the emissions created are actually quite high, sometimes higher than the original product, sometimes lower, but nevertheless, it's not as simple or as clear cut as remanufacturing, and certainly nowhere near the impact of remanufacturing around waste and emission reduction. The other downside of recycling is it's often priced to be more expensive than new. Put it that way. I choose my words carefully there because sometimes it can be less expensive to do, but what we find is incumbent suppliers tend to price a recycled option higher than their new alternative, partly because they prefer to sell a new and it's a whole lot easier for them. A key watch out here as well is watch out for recycled content and recyclable, because as we've just discussed, recycled content is not particularly emission reducing, and recyclable is a term that we really struggle with because that means it's up to you. So you say to a manufacturer, hey, it says recyclable on the label. Will you come and take it back? And they say, no, that's your problem. We've sold you that product. Now, in an office environment, that means the poor old office manager who's got a billion different things to do is then in charge of and responsible for finding someone who'll take the plastic from the old task chairs. And then they have to find someone who'll separate the plastic because those recyclers don't take a whole chair, for instance. So we think recyclable is an abrogation of responsibility from the original manufacturer, and frankly, if the manufacturer doesn't take it back, they're not very circular anyway. So we think that's essentially a cop-out greenwash solution, both recyclable and recycled content, and we'll get more on that a bit later. And then the final in the circular economy hierarchy, and obviously the least preferred, is waste to energy. It's super easy to say, oh, look, just get it out of here or send it off to waste. Someone will burn it and maybe someone will get some energy out of it. But that's still incredibly environmentally damaging. There's all sorts of particulates that come off that need to be dealt with ideally, or otherwise they're vented to the atmosphere. And obviously it's not very efficient, and perfectly good products going into essentially a very large furnace does not feel like the right solution in terms of retaining the value of both the environmental and the economic value of those. So we just say, look, avoid waste to energy, just as you want to avoid landfill. So now waste to energy is the new landfill. No one wants to send stuff there. So that's a quick overview of the circular economy. If I then go to why the circular economy can get you to net zero, there's an interesting discussion that we have with our clients, specifically around furniture, because obviously we know furniture very well. So please bear with us if we use the furniture example. So what we say to clients is, okay, you can't get to a 90 to 95% reduction in your furniture emissions in your first project. What we'll help you to do on the left-hand side there is you've got existing furniture office. We'll use some of that in the next project. We'll remanufacture that. We'll then externally source some product that we can remanufacture, and we'll add to that whatever new product we need to meet the wow factor design guidelines coming from the architects, because that's really important. But we'll make sure that that new furniture can be remanufactured for further lives, which means that on the second circular economy project, all of that furniture can be remanufactured and reused. And what that means on the right-hand side is that first project certainly achieves a 50% reduction, which, remember, according to the SBTi standard, that's what's required for 2030. But the second project should be able to get to then a 90 to 95% reduction. So there you are, you've hit your target there. So what's happening then is people are thinking not just about a one-shot solution that gets you to a 90 to 95% solution. We recognize that's unrealistic for some products, but on the other hand, this is all about pathways, and we've got till 2050 to get there. So let's do it in a stepwise fashion, making good solutions that make the next step easier. My mum's a golfer, or used to be a golfer, and she always said to me, Greg, play the shot that makes the next shot easy. And that's what we talk about here in terms of the circular economy. Moving on then to how we summarize all of those. Remember, we're keeping this pretty short. If I summarize those, there's this comparison matrix. On the left-hand side is a financial benefit, where benefit being low at the bottom, so it costs more. In the middle, costs about the same, and up the top, you're saving money versus traditional solutions. And on the bottom, carbon emissions impact from low to high, left to right. If I plot all of those solutions we just discussed on this 2x2, what you see there is in the bottom left corner, which is the undesirable limited impact with very expensive cost, you've got your recycled products, your on-site renewables. As you move up and right, we've got energy efficiency in the middle, carbon negative materials on the bottom right, grid renewable energy, given that you can buy that for roughly the same cost, and does have a pretty good impact. And then up the top, what your standout winner there is your remanufactured products, where you're saving money and you're having a big impact, because remember, 43% of the emissions of a building are in the fit out, and just about all of that is the embodied carbon, which is where your remanufactured products really have a big impact on that. This prompts a couple of questions. Why is it then that we are focused traditionally on the bottom left corner, which adds cost and won't get us to net zero, when actually what we should be focused on is the top right corner, which can get us to net zero and save us some money, or at least do that cost effectively? So a philosophical question there, but our view is that that's because both recycled content and on-site renewables are a sort of bolt-on or add-on features to conventional solutions offered by incumbent suppliers. So if you don't want to change anything, you just say, sure, we'll just put a bit of recycled content in that, or you can bolt a solar panel to your roof. And you can feel really good about that, but that's not really going to solve the problem. So the conclusion from that then is the world needs to change how it thinks about these sorts of solutions, from a very incremental recycled product and on-site renewable to a more systematic remanufactured product and grid renewable energy. So if I summarize all of that with some key takeaways for everyone, number one, switch to grid renewable energy. It's cheap, it's easy, it's quick, and we can do it. And Susan, in fact, did that for RIPE. Thank you, Susan. It was a largely painless process. Secondly, buy remanufactured FFE and materials. But note that you're probably not going to find those from just reaching out to your incumbent suppliers and saying, hey, do you have a remanufactured product? They're going to say, well, we've got a recycled content and it might be recyclable. Do you want to buy that? We can't settle for that because that won't get us there. Thirdly, design for reuse and remanufacturing, because an element of this, so for instance, joinery, we see a lot of joinery specified that involves glues and fixing elements to other elements with irreversible fixings, which means that, I mean, let's take, for example, the modern fashion for essentially built up bleacher blocks or stages within sort of pseudo staircases within offices. Often they're made of joinery, and we've tried to pull a few of those out of offices, and you end up just frankly with scrap wood and matchsticks, because they all get destroyed by the time you try and undo the glue on those. So please don't do anything like that. Make sure whatever you're going to put in is designed for reuse and remanufacturing. So for instance, instead of joinery item bleachers, you can nowadays get bleacher blocks that stack together very securely with clamps to make sure that they're very stable, that can then be lifted out block by block and reused in another situation and remanufactured very easily, and there's a whole market for those as well. And then finally, find the carbon negative materials. Also, you're not probably going to get those from your incumbent suppliers, but get out there and have a look. I've given a couple of examples earlier on. And of course, key thing that might help you is the right team's always happy to point you towards proven high quality solutions for points 2 and 4 there. So that's the end of this session. Remember, we promised to keep it pretty short. I think Kevin's just joined us right at the end. This will be recorded, but remember, we've got another session coming on the 5th of December, which is our third programmed session. We'll then take a break over Christmas and come back with points with modules 4 through to 10. The next one promises to be really interesting. It's about what does a net zero carbon workspace look like. This is one for the designers. We're starting to think, well, okay, there's an aesthetic starting to merge. So this session is all about fleshing that out a little bit and it'll be a little more interactive to get a discussion going. Is there an aesthetic that logically comes from a net zero carbon approach?